Hi, my name's Andrew McLaren, and I want to help you solve challenging trinomial factoring problems like this third one. These are a lot harder for students typically with the ways teachers traditionally teach factoring, with like a little X with a couple things where people don't really understand why they're being related in that way. So the better way, in my opinion, is if you use FOIL and that structure of FOIL, but do it in reverse and label things clearly. And if you do that, you can do these harder problems fairly easily. And you can use the same method to do these easier problems as well. So I think it's a better way than the X, because people just don't understand how those parts are being related because they're not labeled, and then that doesn't really help them much when they get to these more difficult ones. And people are often told to guess and check, but we can have educated guesses or guesstimation here that helps us a lot with this structure. So if we're looking at a trinomial like this and we're trying to factor, it is important to keep in mind that you're taking two things that are oftentimes represented as parentheses, and then there's like a number, a number, a number, and a number, and then some sort of operation between those numbers as well, kind of in the middle here. And those will get multiplied. And when we do that, we get this trinomial. And in doing so, this first term right here, that comes from the FOIL step, f. So that's like the first two terms being multiplied by each other right there. And then if we're thinking about the middle thing right here, this second part of the trinomial, this is going to be a combination of the outside and the inside being combined. So there's this outside, and then I'm going to do a slightly different color for the inside here, but they're very closely related because they'll ultimately add up to this negative 5x. So that comes from, in this case, what I've represented is the outside there, and then the inside as well, which would be this multiplication. So you've got this, all these steps here, and then you've got the similar, this is the last, so that would be like the FOIL, the L there, and that's going to be the two back terms multiplied by each other. And what you can do here is essentially relate the parts that you know and list out what are possible combinations that might lead us towards um, this trinomial. So the first thing that I typically do is I look at like my first, and I ask myself what two factors would give me 2x squared. And really this is going to be like 2x and x. Those are really the only two that work here, besides a negative 2x and a negative x. But that's not usually going to be the case with one of these. So you can see that we've got these two things that are being multiplied. That gives us the first. And so that means there's either a 2x in the first term, or like the second parentheses, the first term in that. So then we've also got this last, which to me, I know that there's two numbers that are going to be multiplied to give me negative 3. So I'm thinking that's going to be a negative 3 and 1, or 1, or a negative 1 and 3. So it's going to be some combination of these two. And then what we're going to have is we've got this outside and the inside, which are going to be two numbers that are being multiplied, and then they're being added to two other numbers that were multiplied. And so you're basically taking these two factors that are like maybe these terms for the first or the second part of these parentheses, and you're considering and you're guessing and checking in here. And the important thing to keep in mind is the outside and the inside. When you combine those, that gave you a negative 5x. So if we look at that and we're considering this, it's a little bit of guess and check. This is where I do like the guess and check, and I kind of agree with what people say online, where it's like, oh, okay, there's um our first terms there, maybe a 2x and an x. And that means that in the outside, then I'm going to have my 2x here. And then on the inside, there's an x there. And so I know two of the terms now that are being combined in the outside inside portion to give us the second term in the trinomial. And then it's just a matter of kind of guessing and checking and being like, well, if I want this to be a negative 5, that probably means that I have my negative 3 here and my 1 here. Because when we do that, we get negative 6x plus x. And when you do that, that should give you negative 5x. So then you know that you've got the negative 3, which was multiplied by 2x, and you've got the 1, which was multiplied by x. So this is where you got to be a little bit careful, because you know that the negative 3 and the 1, they're being combined with like 2x. So I would say that like 2x was being combined with this outside term. So this is going to be that outside piece. So you can kind of see outside right there. So this is going to be a negative 3. And then we would have a 1 there. So you could think about this as these two things being added, or another way of writing this would be 2x plus 1 and then x minus 3. So that is how I would go through this reverse FOIL method. So I'm keeping track of what is my first and last, my outside and inside, and how those get put together to give me that trinomial. And you can then easily double check that by going through the process of actually like being like, oh yeah, if I do that, then I do get the 2x squared, and I get the negative 6x, and I get the plus 1x, and I get the minus 3 for that last term. So it's fairly easy to double check. But the key here, the thing that I think is much better about this method, is how this lets you write out the outside inside terms and what it solves out to, and lets you plug them into this relationship. So this kind of takes place of that X technique that people will do when you have like x squared or like -1 or something like that. That's fairly easy. So these easier problems, you don't need to do this method, but this makes it so much easier on the more difficult ones. So here we have an easier problem where we've got x squared plus 3x minus 10. So it seems like one that you may be able to use that other method for, but I want to help you see how the reverse FOIL, how this would work with this. So I'm seeing that there's an x squared. So I know that my first term right there is going to be just 1 and 1. It's either 1 and 1 or like a -1 and a -1, but that's pretty rare that's going to be our factors. Sometimes that is the case, so it's good to write out the negative options as well. And then we have our last right here, which is going to be something that times something else with this right here. And then our first is kind of like these guys right here being multiplied. So the last is going to be two things multiplied out to -10. So a couple options maybe would be a -5 and a 2. So that might be like a -5 and a 2 in there, but I'm not sure if that's actually the case or not. It could also be a -2 and a 5. And those are really it for our whole number options here. Sometimes there's other options that aren't whole numbers, but let's just work with these for now and see if we can get something that works out. So I can see that the basically these first terms, this x squared, it's almost certainly going to be x and x. And if we think about the outside and the inside, when we combine those, we're getting a positive 3x. And another way of considering this is that this is 1x, or -1x, -1x. That really keeps track of the x's more appropriately than just doing like ones for like the x squared. And that comes into play here with the outside and the inside, because we're going to end up combining things with x's in there to get a 3x. So it's important to just recognize that relationship between those parts. And that should then give us two things that we're putting together, the outside and the inside, and that should give us that 3x. So I'm just kind of looking at this, I'm thinking like, okay, it's a positive 3. Maybe we want the -2 to be present. So I'm thinking that we're going to want to work with the -2 and the 5 almost certainly for these two terms here. Because that means that one of them's it's more positive than it is -3x. So if we're looking at using 1x for these first two terms, the positive ones right here, then it looks like you're going to have a -2 and a +5. And when we do that, you get a -2x plus 5x. And yep, that ends up giving me a +3x. So these easier problems, you can solve this way when you write out the outside inside terms and keep track of it that way. And it actually helps me make sense of it, seeing where the x's are coming into play here. So that's one way to go ahead and solve this problem. And then you can imagine that we've got, that kind of messed up the color there. You could imagine now that it doesn't really matter which one is which because you've got the x's here, but to match our terminology here that we use with the outside was the one with the -2, and the inside was when we had a 5 there. So we've got like a +5. So we can think of this as these two things being added up like that, or this could be maybe written out as x plus 5 in parentheses times x minus 2 in parentheses. And you can go ahead and factor that or FOIL that and see that that actually does give you the original trinomial. So if you do one, you can think of this as factoring going forward and foiling going backwards, or they're just reverses of each other. So we want to do a reverse FOIL when we're doing factoring, and writing this out works for these easy problems as well. So I have a couple problems worked out here that I'd like to use to explain how foiling and factoring are related. And to help us really understand that, it's important to remember factors are just two things that are being multiplied that give you a number. So if you've got a rectangle, like you can see I've got this guy right here, where I've got this rectangle, and on one side there's one factor, and the other side is a different factor. So they're basically edges of a rectangle, so you could think of it as like a length and width of a rectangle. So if we look at this in terms of breaking it down with our x plus 1 and x plus 2 inside of those parentheses, then you could imagine a big rectangle where you have unknown side lengths of x, and then you're adding 2 more onto that and 1 more onto that. So when we're foiling, the reason that you have to do the FOIL and do the multiplication is because there's this x term that needs to be multiplied by x as well, because that's the first. But there's also, it needs to be multiplied by the last term there, that 1, because if we don't, then you're not accounting for all the pieces of this rectangle. So you can think about that in a way. It's easier to do that with the addition than the subtraction, because subtraction you kind of take away some area, so it's kind of like there was an x and now you've got like a negative area, so that can be a little bit harder to represent visually. You could imagine that instead of drawing this out where like the negative has some positive distance from it, you could actually take that away from this and represent that sliver as a negative area. So there's kind of like a -7 being taken away. So that's kind of what's going on conceptually, why you're multiplying those terms in that certain way. But you can think about the outside and inside, what I had been doing in green and this light green, as being kind of like here, and you got your first and last. So the first and last are pretty easy for most people to kind of see, like, oh yeah, I see where those factors do come from. But then you need to combine these two boxes, the outside and the inside, to get the middle term, because oftentimes they're both going to be something like this, where you've got like x and x. So it's terms that have that common variable in it, and so you can combine them. And that's kind of what's going on here. So you can think of like, okay, well, I'm getting my first to my last, those are pretty easy, but then I need to combine this outside and inside. So I can do that with this way of keeping track of outside and inside and what it should be adding up to. So I've got another problem here, x squared minus 22x plus 5. And I've got a couple options for the factors for the first and last. I knew that when I multiplied them out, and then added up those two different sets, then it was going to be -22x. So there was a couple different options where I was like, does that work? No, that doesn't work. Does this work? No, that doesn't work. And then eventually I was able to get 20 and a 2x, but that was positive. So we needed to do the negative factors on here, so you can kind of see that as like -5 and -1, and that actually worked out when I used those in here. So you can see that that is shown below, where we've got like this would be a -20, and that would be a -2. So we do get a -22x when we have those both be negative on those second parts of the parentheses, not the x, but just the number. So you can kind of see it as a guess and check, where we're using our first and last to be like, what options am I plugging into this line where I've got all these two things that are being multiplied and then added together, and that works out pretty well. So and then you can imagine that as like, oh, there's some sort of box now where this is one length and this is a different width, and we're needing to combine those four different pieces of the square. So relating that back to that visual, you can think back to like, well, my factors are like two things that when I multiply them together, it gives me this larger area that I have represented by my trinomial. And I've got another problem here, just kind of worked out so you can see that it's got the same sort of stuff where we've got our factors. These are options to plug in. So it is kind of guess and check where you're kind of throwing things in here and you're checking. But I find it a little bit easier to keep track of this with the line written out that way, as opposed to just kind of throwing the numbers together and mentally keeping track of it all. It's just a little too much to do in your head. Thank you for McLearning with me. Before you go, please check out the following services that I offer with my business. So if you click the link in my videos, this goes to my website. I might be changing it from Podia because I'm no longer doing the interactive videos for sale. I might put those up for free. But most of my other services are linked here. So you can see that I've got like a Teachers Pay Teachers and a Wyzant. The Teachers Pay Teachers has a lot of my assessments that I have for like the NGSS, as well as lessons that I made when I was actually a teacher in the classroom. So I've got quite a few things like CERs and other things on there. If you want to get one-on-one live support from me, either like with science or like working on like teaching support lessons and that kind of stuff, you can sign up through Wyzant. I have a link to there where you can contact me there, and we can schedule hourly appointments. And I've got a few other things on here like a Facebook page and other social media. And if you're interested in getting professional development with me for like a team of teachers, a whole page with information on that. So yeah, feel free to check that out. Thank you.